Hey guys, welcome you all in T3P Technology to the Point. In this video, we will talk about AWS Solution Architect Associate exam related question, and these questions are very special. The reason is here we are not going to talk about the fundamental questions. So far we have gone through many questions, 100 plus questions, that is level 1, and few questions a bit complex, but here I'm going to cover the complex questions with their detailed explanation. Not only we will go through the questions, we will also learn about the services. So what are the services covered in this video? We will cover document DB, we will cover Elastic ACID for Redis, we will cover DAX, that is DynamoDB accelerator, then we will cover Elastic ACID for Memcached. Also we will cover the compute side like instance store based EC2 instances, EC2 instances with EFS mount point, AWS based EC2 instances, and then we will cover in the last EC2 instances with access to S3 based storage. This is from the compute side. If we will talk about the services, we will cover the Amazon SNS, Amazon MQ, Amazon SQL standard and FIFO both, and we will talk about the versioning and MFA delete or service what we are having in AWS, and then we will talk about some networking services to migrate the infrastructure from the on-premises to the AWS clouds, that is AWS Direct Connect. We will talk about site-to-site VPN. We will talk about Snowball as storage. So that means that we not only we are preparing for the exam, but also we are learning for our technical knowledge. So without wasting time, let's get started with the questions. So let's talk about this question. In this question, they are asking, a healthcare startup needs to enforce compliance and regulatory guidelines for objects stored in Amazon S3. One of the key requirements is to provide adequate protection against accidental deletion of object. As a solution architect, what are your recommendations to address these guidelines? We need to select two options out of given options. So the first option they are talking about, create an event trigger on deleting any S3 object. The event invokes an SNS notification by email to the IT manager. This option don't seems to be correct. The reason is setting an event triggers after object deletion does not meet the objective of preventing object deletion by mistakes, or we can say by accidentally. So this is not the correct choice here. Next option is about establish a process to get managerial approval for deleting S3 object. This option for getting managerial approval doesn't seems good to me, because it's just for distraction, we can say. Next option they are talking about, change the configuration on AWS S3 console so that the user needs to provide additional confirmation while deleting any S3 object. If this is possible, then it's a good option, but unfortunately we don't have such provision to set up S3 configuration to ask for additional confirmation before deletion. So this is also not correct. Next is enable versioning on the bucket. Yes, this is correct. What exactly the versioning? Whenever there is any modification about on the object, or we can say the deletion or the modification, whatever it is, what it do, it does not delete or remove the objects permanently or override the objects permanently. What it do, it keeps the old data with some ID and the updated data with an updated ID. So whenever we need, we can go back to the earlier version and we can restore it, retrieve it. So in this case, we can have this in versioning can help us to prevent data for accidental deletion. Next is enable MFA delete on the bucket. Yes, this is also seems correct to me, because to provide additional protection, multi-factor authentication delete can be enabled. MFA delete require secondary authentication, as you know, to take place before objects can be permanently deleted from the S3 bucket. So these two options are correct for me. So we will go with option number 4 and option number 5 for this question. Let's talk about next question now. Let's talk about this question. In this question, they are asking, a media company wants to get out of the business of owning and maintaining its own IT infrastructure. As part of this digital transformation, the media company wants to archive about 5 PB, that is petabytes of data in its on-premises data center to durable long-term storage. As a solution architect, what is your recommendation to migrate this data in the most cost optimal way? So the first option we are having, set up AWS direct connect between the on-premises data center and AWS cloud, and use this connection to transfer the data into AWS Glacier. First thing here, we need to look for the most cost optimal way. So whenever we talk about to establish or set up a direct connect, that requires huge investment, okay, and it takes more than a month to set up. So this is not the correct answer for this one, so we will not go for this one. Next option, they are talking about set up site to site VPN connection between on-premises data center and AWS cloud. Use this connection to transfer the data into AWS Glacier. So first we understand what exactly site-to-site VPN is. Site-to-site VPN enables us to securely connect our on-premises network, or we can say our branch office, to the Amazon VPC. That means it will connect our organization to the cloud, and this VPN connection are actually good options. We can say the good solution if we have an immediate need, like in this case, and have to low to modest bandwidth requirement. If we require very less bandwidth or less data, then it's good, but here the volume size is 5 petabytes, so that is not possible. We can say it's gonna take months to transfer this data through this way, so we will not go for this option also. Next option we are having, transfer the on-premises data into multiple Snowball as storage optimized devices, and after that copy the Snowball as data into Amazon S3 and create a lifecycle policy to transition the data into AWS Glacier. This option seems correct to me, but for the timing we will not go over this one. Let's check the last option what we are having. Transfer the on-premises data into multiple Snowball as storage optimized devices and copy the Snowball as data into AWS Glacier. See, here the thing is, we can't directly copy the data from Snowball as data to AWS Glacier. We need some mediator for that one. So what we will do, so this option is not correct, I'm sure for that one, and we will go for this option because we need a mediator. So what we will do, first we will transfer the on-premises data into multiple Snowball as storage optimized devices, then copy this data from this to S3 bucket, and after that later point of time we can create a lifecycle policy to transfer this data into AWS Glacier. As we know, Glacier is the most cost optimal way to store our data for longer period of time. So this is the correct process, or the way we can say. So we will go for the option 3 for this question. Let's talk about next question now. In this question, they are asking a US-based non-profit organization develops learning methods for primary and secondary vocational education delivered through digital learning platforms, which are hosted on AWS under a hybrid cloud setup. After experiencing stability issues with their cluster of self-managed RabbitMQ message brokers, and the organization want to explore an alternate solution on AWS. As a solution architect, which of the following AWS service would you recommend that can provide support for quick and easy migration from RabbitMQ? So the option we are having, Amazon SNS, that is simple notification service, Amazon MQ, Amazon SQS Standard, Amazon SQS FIFO. Let's talk about these services one by one, what we are given in the options, so we will understand better. First, we will go through the Amazon SNS service, that is simple notification service. What exactly this service is? It is highly available, durable, secure, or fully managed power of messaging service. But the problem here is SNS does not provide support for migration from RabbitMQ, as it is fully managed power and sub messaging service. So we will not go for this option here. Next, we are having Amazon MQ. So Amazon MQ is a managed message broker service for Apache ActiveMQ that makes it easy to set up and operate message broker in the cloud. So if an organization is using messaging with existing application and want to move messaging service to the cloud quickly and easily, then AWS recommend Amazon MQ for that purpose. So in this case, we will go with Amazon MQ as a right choice. Let's talk about other services also to understand better. If we will talk about Amazon SQS standard service, Amazon SQS standards offer a reliable, highly scalable hosted queue for storing messages as they travel between the computer. Again, SQS standard does not provide support for the migration from this one, so we will not go for this service again. And the last option we are having Amazon SQS FIFO. FIFO stands for first in first out. So what exactly this service is? It has all the capabilities of the standard. So it's so to use this one, when we use it, whenever there is a operation or event is critical or where duplicates can't be tolerated, in that case we use Amazon SQS FIFO service. But the thing is, SQS FIFO service does not provide support for the migration of from private MQ, so again we can't go for this option. So there is only one option where AWS recommend if any organization using existing messaging services, if they want to move to Amazon, or we can say to the cloud quickly and easily, then Amazon MQ is the best choice for that service. So we'll go for option 2. Let's talk about next question now. In this question, they are asking, a research group at an Ivy League university needs a fleet of EC2 instances operating in a fault-tolerant architecture for a specialized task that must deliver high random I/O performance. Each instance in the fleet would have access to a dataset that is replicated across the instances. Because of the resilient architecture, the specialized task would continue to be processed even any of the instance goes down, as the underlying application architecture would ensure the replacement instance has access to the required dataset. Which of the following option is the most cost optimal and resource efficient solution to build this fleet of EC2 instances? The options we are having: use instance store based EC2 instances, use EC2 instance with EFS mount point, use EVS based EC2 instances, use EC2 instances with the access to S3 based storage. So the requirement here is it need to be a fleet of EC2 instance operating in a fault tolerant architecture, and each instance should have access to a dataset that is replicated across the instances. So, and the requirement here is specialized tasks which we are looking for would continue to be processed even if any of the instances goes down, as the underlying application architecture would ensure the replacement instance, and this replacement instance should have the access to the required dataset. So we are looking for most cost optimal and resource efficient solution to build this EC2 fleet. So to understand this question, we need to understand these things what they are looking for. The option we are given. So first option is use instance store based EC2 instances. So what exactly this instance store based EC2 instances? Instance store provides temporary block level storage for our instances, and this storage is located on the disk that are physically attached to the host computer where we are hosting these EC2 instances. Instance store is ideal for the temporary storage of the information that changes frequently, such as buffer, caches, or we can say the scratch data and other temporary content we are looking for. So for the data that is replicated across a fleet of instances, such as load balance pool of web servers. So instance store volume are included as a part of the instance usage cost. So this seems to be a viable option for this question, but we will not select right now. Also, it's provide high random IOPS performance at the lower cost. So that is the good part to choose this option. But before selecting this option, let's go through the other options as well. Next option we are having use EC2 instances with EFS mount point. So using EFS implies that extra resources would have to be provisioned, as we are looking for most resource efficient solution. So this is ruled out for this question. So we will not go for option 2 here. Next option we can check use EBS based EC2 instances. EBS based volumes would need to use provisioned IOPS as the storage type, and that would incur additional costs. As we are looking for the most cost optimal, again this need to be ruled out, because if we provisioned extra IOPS, we need to pay higher for that one, but we are looking for cost optimal, so we will not go for this one. Next option is we are having huge EC2 instances with access to S3 storage bucket. So using EC2 instances with access to S3 storage bucket does not deliver high random IOPS, so it's not good for the performance which is required in this question, so we will not go for this one. So we are having instance store based EC2 instances that is having high performance and that can be used for temporary storage for where the data is changing, like here we are need to be replicate the data, so we will go for this option here. If you are not satisfied this one, you just mention in the comment box what you find best according to you, so it can help others as well. Let's talk about next question now. In this question, they are asking the CTO of an online home rental marketplace wants to re-engineer the caching layer of the current architecture for its relational database. He wants the caching layer to have replication and archival support built into the architecture. Which of the following AWS service offers the capabilities required for the re-engineering of the caching? So the requirement here is he wants the caching layer to have the replication and archival support built into the architecture. So that is the primary requirement for this question. So let's see the options what we are having. Document DB, Elastic Cache for Redis, DynamoDB Accelerator, that is known as DAX as well, Elastic Cache for Memcache. So before going through the answer, let's go through the services one by one, what exactly they are. The first option we are having document DB. So what exactly the document DB is? Amazon document DB is a fast, scalable, highly available, fully managed document database service that supports MongoDB workload. So document DB cannot be used for the caching layer. So the thing is, it can't be used here. So this is not the correct choice for this question. Next we have Elastic Cache for Redis. Amazon Elastic Cache for Redis is a blazing highly fast in memory data store that provides some milliseconds latency to power internet scale real-time applications, and it's the great choice for the real-time transactional analytical processing use cases such as caching, or we can say the chat or messaging, gaming leaderboards. That means real-time transactions. We use the Elastic Cache for Redis. Here the thing is we are using for caching layer, so it seems correct here. But before going through the choosing this one, let's go through the other options as well, so we will understand better. We will talk about the third option, that is DynamoDB Accelerator. That is a key value and document database that delivers single digit millisecond performance at any scale, and it is fully managed multi-region, multi-master, durable database with built-in security. But the problem here is with DAX is it cannot be used as a caching layer for the relational database. That's why we can't go with this option here. Next option we are having Elastic Cache for Memcached. So Elastic Cache for Memcached is a Memcached compatible in-memory key value store service that can be used as a cache or a data store. But the problem with this Elastic Cache for Memcached is it does not support the replication and the archival snapshot, which is the requirement here. If you see the questions, they want the caching layer to have the replication and archival support. It is feasible with the it can be used as a caching layer, but the thing is it don't provide replication and archival support, so we can't go with this one. So correct answer for this question we are having Elastic Cache for Redis, so we will go with this option. Let's see what we have next. So guys, that's it in this video. I hope you find this video helpful. If you find it, then don't forget to click on like button, share with your friends who are preparing or who want to learn cloud, and don't forget to subscribe this channel and ask your friend as well, so we can help as many people as possible. Also don't forget to connect with me on Telegram, where you can get the free learning resources, means the documents which I can't share over the YouTube. So you will get the cheat sheet, interview questions, practice questions, so many things we are having for free. So connect with me on Telegram. You can find all the links in the description box. See you in next video.